Hi everybody, and welcome to our Task 4.10 video. And in today's video, we're going to continue talking about inequalities. We have 4 different learning targets today. The first is I can create an inequality to model a situation. So we're going to be creating inequalities that represent a real world scenario today. The second learning target is I can use inverse operations to solve linear inequalities in one variable. Now that is a review learning target. We've already learned how to solve inequalities. We're going to be doing that again today, only we're going to be solving the inequalities that we created. The third learning target is I can interpret the solution set to an inequality. So we're going to be looking at what our answer means in the context of a problem. So we're going to be interpreting, which means what does it mean in the context of a problem? Last but not least, I can justify my reasoning about inequalities. So I can explain my thinking and justify my answers. So let's go ahead and get started. In the first 2 problems here, these are kind of a warm-up for what we're going to be doing today, and it's an example of where inequalities might occur in a real-world scenario. So here's the first problem. It says Ellie and Sarah are taking a road trip. Ellie has $40 for gas, and gas costs $3.50 per gallon. Sarah says that Ellie has enough to fill up the 12-gallon gas tank. Is she correct? Justify your answer. Now, there are lots of different ways that you could approach this problem. In order to figure out if Ellie has enough money to fill up her 12-gallon tank. One option is to figure out how much it would cost to fill up the 12-gallon gas tank. In this case, because gas is $3.50 per gallon, and we know that it's a 12-gallon tank, option number 1 is to multiply 12 gallons times $3.50 per gallon. And that tells me, and I'm going to use my calculator to do this, 12 times 350, I guess 42. That tells me that it's going to cost me $42 to fill up the tank. Since Ellie only has $40, that makes me think that she does not have enough money to fill up her tank. So I would say that Sarah is not correct. Ellie does not have enough money to fill up her tank. Because it would cost $42 to fill up the tank. And Ellie only has $40. Now that's option number 1, is figure out how much money it would cost to fill up the tank and then see if she has enough money. Option number 2 is a little bit of a different approach. Option number 2 is to figure out how many gallons she could purchase. So in this case, for option number 2, if we know that Ellie has $40 and that gas is $3.50 per gallon, we could do 40 divided by 350, and that's going to tell us how many gallons she could buy. So 40 divided by 350 would give me 11.4. I'm going to round that to 11.43. So 11.43 gallons. This means we still end up with the same final answer, that Ellie is incorrect. And the reason it's going to be incorrect is because 11.43 gallons is not equal to 12. So we would say Sarah is incorrect. Ellie only has enough money to buy 11.43 gallons of gas, which is not 12. So Sarah is wrong. We can't buy all 12 gallons. Now, when it comes to how you decide to do this, either one of option number 1 or option number 2 is fine. You can choose to use whichever one makes more sense to you, as long as at the end you come to the same conclusion, which is that Sarah is ultimately wrong here. Ellie does not have enough money to do the full filling up of her gas tank. Now, in problem number 2 here, here's another example of where an inequality comes up in the real world. Andrew is buying Yeezys to resell. Andrew has $3,000 and each pair of Yeezys costs $350. What is the most he can buy? Justify your answer. Now, in this case, I want to know how many pairs of shoes Andrew can buy. And I know that he has $3,000 and each pair costs $350. So in order to answer this question, I'm going to take the $3,000 that Andrew has, and I'm going to divide by 350 to see how many pairs of shoes he can buy. That ultimately gives me the number 8.57. Now, because this is a real world scenario, in the real world, you're not going to ever be able to go to the store and say, I'd like to buy 8.5 pairs of shoes. So because this is a real world scenario, we need to sort of make sense of this in that context. And what that means is that because 8.57 tells me that he does not have enough money to buy 9 pairs, the most numbers of pairs of shoes that he can buy is going to be 8. So I'm going to say Andrew can buy 8 pairs of shoes because 3,000 divided by 350 is equal to 8.57. So he does not have enough money to buy more than 8 pairs. It won't get him all the way to 9 pairs of shoes because you can't buy like 8.5 pairs of shoes. Okay, this is the first sort of way that we're going to be looking at inequalities in the real world. The next way that we're going to be looking at inequalities in the real world is where we have to create our own. So this problem says Elvira, the cafeteria manager, has to be careful with her spending and manages the cafeteria so that they can serve the best food at the lowest cost. In order to do this, Elvira keeps good records and analyzes all of her budgets. Now, this is a very real thing. If you're somebody who works for a restaurant or a cafeteria or any kind of business, you need to have a very strict budget so that you can make sure that you don't overspend and that your business is successful. Problem number 1 says Elvira's cafeteria has those cute little cartons of milk that are typical of a school lunch. The milk supplier charges 35 cents per carton of milk, in addition to a delivery charge of $75. What is the number of cartons that Elvira can buy if she can spend at most $500 for milk? The first thing we're going to do here is we're going to define a variable. Now, when I say to define a variable, it means we need to literally choose a letter and tell us what it means. So, in this case, the question says, what is the number of milk cartons that Elvira can buy? If the question is asking me how many cartons of milk Elvira can buy, then my variable is going to represent the number of cartons of milk Elvira can buy. Now, I like to use the variable x. So x is going to equal, in this problem, the number of cartons of milk Elvira can buy. Whatever the question is always going to be what you use as your variable. So my hint to you would be, whenever I ask you to define a variable, this is always going to be, look at what the question is asking you to find. If the question asks you to find how many pairs of shoes you can buy, then your variable is going to be how many pairs of shoes you can buy. Next, we're going to write an inequality. Now, the reason we're going to be writing an inequality and not an equation is because it says in the problem here that she can spend at most $500. Now, the word at most tells me that this is an inequality. And when we learned about those words, at most, we said at most actually means that the amount she can spend is less than or equal to $500. So I'm going to write some sort of inequality, and at the end, it's going to say less than or equal to $500. Now let's figure out the other side of this inequality, sort of what goes on the other side of that symbol. If I reread the problem, it gives me two pieces of information. It tells me the milk supplier charges 35 cents per carton of milk, and then a delivery charge of $75. Now, what that means is that the 35 cents is going to be a fee that I pay over and over and over again, depending on the number of cartons. So in order to show that in my inequality, I'm going to write 0.35, and I'm going to put the x next to that because that is the value that repeats X number of times, depending on how many cartons I purchase. So if I purchase 10 cartons, I would have to put 0.35 times 10. Now the delivery charge is going to be a one-time fee. So I'm going to go ahead and just write plus 75 because I'm only going to write that, I'm only going to pay that one time. I'm going to pay the $75 one time, and I'm going to pay the 35 cents over and over and over again. That's why there's no X next to the 75 because it's only one time, and there is an X next to the 35 cents because it does repeat. All right, that's the first two steps to doing this problem. The next step, part B, says solve the inequality from part A. And then we want to write our answer as both an inequality and an interval notation. Now, because I like to be organized when I solve, I'm going to go ahead and just copy this inequality down into this space. Now, in order to solve this, I'm going to start by subtracting the 75 on both sides. And this is a case where I do think that having a calculator would be really helpful. So if you're somebody who has a calculator or wants to use an online calculator, this is a good time to do that. So I would have 0.35x is less than or equal to 500 minus 75 would be 425. Then I need to divide by the 0.35 on both sides. And that's going to give me x is less than or equal to 425 divided by 0.35 is not an answer I know off the top of my head. So 4.25 divided by 0.35 is 1214.2. And then I know it says 8, but the 5 that comes after that is big enough to bump up the 8 to a 9. So I'm going to say x is less than or equal to 1214.29. Now that means that when I want to write my answer as both an inequality and an interval notation, the inequality of my answer would be exactly what you have here. So x is less than or equal to 1214.29. In interval notation, less than or equal to would be sort of the left side of the graph. We're going smaller. So in interval notation, that would be negative infinity, comma 12.14.29, and I'm going to use a bracket here because of the equal to. If you find it helpful to sketch a little graph in order to graph this so that you can visualize your interval, then go ahead and do that. A graph is a great strategy for being able to connect your interval and your inequality notation. Now that is great. We've solved our inequality, but this is a real world problem. So what we're going to do last is we're going to look back at the context of the problem, and we're going to describe in words the number of milk cartons that Elvira could buy to stay within her budget. Now our answer says that x has to be less than or equal to 1214.29. Now that includes any number that's less than that, including negative numbers. It also means we're including all decimals. Now, in this case, since X stands for the number of cartons of milk that she can buy, it doesn't make sense to say that she could buy a negative number of cartons of milk, and it doesn't make sense to say she could buy a decimal number like 1214.29. So, in order to interpret this in the context of the problem, I need to consider what numbers actually make sense in this real world scenario. In general, what you want to consider, and this is sort of a general rule, you want to consider two things. So the questions you're going to ask yourself are, first, would negative numbers be okay in this scenario? Now, sometimes negatives might make sense, but in this scenario where we're buying cartons of milk, it kind of doesn't make sense to use negative numbers because you're never going to buy a negative number of cartons of milk. The second thing you want to consider is, would decimals make sense in this scenario? So in this case, would negative numbers make sense in this scenario? In this case, the answer would be no. And would decimals make sense in this scenario? In this case, the answer would be no. Now, by saying X is less than or equal to 1214.29, we are technically saying that negatives and decimals are okay. So what we need to do in part C is clarify that what we really mean here is only positive numbers and only whole numbers of cartons of milk. Can't have decimals. So here's how we would say that. Elvira can buy up to 1,214 cartons of milk only. So in this case, it's not all the negative numbers, it's not decimals. She can only buy up to 1,214 cartons of milk. Okay. For problem number 2, it says students love to put ranch dressing on everything, so Elvira needs to keep plenty in stock. The students eat about 2.25 gallons of ranch each day. Elvira started the school year with 130 gallons of ranch dressing, and she needs to have at least 20 gallons left when she reorders in order to have enough in stock until the new order comes. For how many days will her ranch dressing supply last before she needs to reorder? The first step here is going to be to define your variable. Now, in order to define your variable, you want to look at the question. The question says, for how many days will her ranch dressing supply last? So X is going to be the number of days her supply will last. Now we're going to write an inequality. Now, the reason I know that this is an inequality is there is an inequality word here in the story. It says she needs to have at least 20 gallons left. Now, when we learned about inequality words, we said at least means greater than or equal to. In order to figure out how many gallons she has, we need to look a little bit before that in the sentence. It tells us that the students eat about 2.25 gallons of ranch each day, and that she started the school year with 130 gallons of ranch dressing. Now that means because they're eating that much ranch, you're subtracting that much from how much you have each day. So she started with 130 gallons of ranch dressing. That's going to be my first number. And she is going to be subtracting 2.25 gallons of ranch each day, which means that's going to repeat. So I'm going to put the X there next to the 2.25, and that's my inequality. The X always goes next to the number that repeats, and in this case, we're subtracting because if you're eating the ranch dressing, it's going away. You're subtracting it for how much you have. Next, we're going to solve that inequality. So I like to be organized. I'm going to go ahead and copy that down. And in order to solve this, I'm going to start by subtracting 130 on both sides. which means that I get negative 2.25x is greater than or equal to 20 minus 30 is negative 110. Then the next step to solving this is going to be to divide by negative 2.25. And when I divide by a negative number, one of my rules about inequalities is that I need to flip the inequality. So this is going to turn into a less than or equal to. And I don't happen to know the answer to negative 110 divided by negative 2.25 off the top of my head, but I'm going to calculate that, and I get 48.8. Even though it says 8, there's an 8 afterwards, so I'm going to bump that up to a 9. So it's going to be 48.89. Now that means that my inequality solution would be x is less than or equal to 48.89. And if I wanted to write that in interval notation, less than or equal to means the left side of the graph. So it goes from negative infinity to 48.89. And since there is a little underline, there is a little equal to, I'm going to use a bracket. Again, if it's helpful for you to sketch a little graph in order to visualize that, then that's what I would do, because a graph is a great strategy for being able to make that connection. Now, let's look back at the context of the problem. In this problem, x stood for the number of days her supply is going to last. Now, because we're saying x could be any number less than 48.89, what we're really saying is it could be decimals, it could be negatives, anything less. But in this context, we don't want to include negatives and we don't want to include decimals. So in this context, what this means is that her supply of ranch dressing will last up to 48 days before she needs to order. Last but not least, let's talk about a problem involving a rectangle. So it says here that the width of a rectangle is 20 inches. If the perimeter of the rectangle must be at least 180 inches, what must the length be? Now, again, to define our variable, you can go ahead and just look at the question. What must the length be? So I'm going to let x be the length of the rectangle. Now, in the story, the inequality word is at least. We want our perimeter to be at least 180 inches. Now, at least means greater than or equal to 180. Now, if you look at this rectangle, it gives us a pretty good visual. Perimeter means add up all the sides. I know that this side is 20 and this side is 20. So if I add those together, I'm going to get that I already am using 40 inches just for those two sides. Now, what I don't know is the size of the length. Now, I'm using the variable x here to stand for length, and there's going to be two of those x's, one for the top and one for the bottom. So in addition to the 40 being part of my perimeter, the other part of my perimeter would be adding in two of those x's. Now I'm going to go ahead and solve this inequality. So I'm going to copy it down. And I'm going to subtract 40 on both sides in order to solve, which means I get 2x is greater than or equal to 180 minus 40 is 140. Then I'm going to divide by 2. And when I divide by 2, I get x is greater than or equal to 70. And that tells me that the size of the width needs to be greater than or equal to 70. So that's going to be my solution, greater than or equal to 70. Now on a number line, greater than or equal to 70 would be to the right. So I'm going to start from 70 and go to positive infinity. I'm going to use a bracket because there's an equal to and a parentheses because we always use parentheses for infinity. Now, looking back at the context of the problem, what does this mean? It means that the length of the rectangle needs to be at least 70 inches. In this case, there is no upper limit. Like, we could go as big as we wanted. It's just at least 70 inches. All right, that is it for today. Thank you guys so much for watching. Have a great day, and I'll see you soon for some practice.